Hey guys, today is March 25th and I'm going to do another LeetCode daily challenge. So let's start. This week it's like we're doing these like interval type problems. So let's see. I kind of want to try to go quicker today because I'm trying to do other stuff, but we'll see. Minimum operations to make a Uni-Value grid. You are given a 2D integer grid of size mn and an integer x. In one operation, you can add x to or subtract x from any element in the grid. A uni-value grid is a grid where all elements of it are equal. Return the minimum number of operations to make the grid uni-value. If it is not possible, return -1. What do they mean? I'm trying to understand what they mean. So we're gonna get a grid 2, 4, 6, 8. They say we can make the following. We can make every element equal to 4 by doing the following. Oh, we could add x or subtract x. So we're gonna add x to this, so +2, subtract x to that, and then subtract x twice. So it'd be like this. Now everything is 4. This seems interesting because I have no clue right off the bat what like toolbox I can use or what technique would be good. Wait, so is it kind of a trick that it's a 2D grid? Like, that doesn't really matter, right? If this was flattened out, it would just be like one dimensional. It would still be the same problem. Like, how many operations, right? Um, since we've been doing a lot of interval, I'm wondering if it's an interval problem. Like, we have a 2 here, we have a 4 here, we have a 6, and we have an 8. Hmm. Let me see this one. 1, 5, 2, 3. On a number line, it would be like 1, 2, 3, 5. And then we have an x of 1. Wow, I have like zero clue. So usually like when they want minimum operations, mm, dynamic programming comes to mind. And if you can't use dynamic programming, maybe like some sort of greedy approach. Um, is it like we just take the middle? We look at the extremes and then we just take the middle? Mm, but then what if there's a bunch of points on this side? Taking the middle would be bad. I don't know. I don't know. Let me look at a hint maybe. Is it possible to make two integers a and b equal if they have different remainders divided by x? Is it possible to make two integers equal if they have different remainders divided by x? So if we had 2 and we had 5 and then x was 2, their remainders are different, and we could never do that because we could add a 2 here, it would be a 4, but 4 and 5 don't work. We could subtract a 2 here, but then it would just be 3. There will always be 1 off. So they have different remainders. Okay, I guess that's a hint. Different remainders will not work. What's another hint? If it is possible, which number should you select to minimize the number of operations? I don't know what number we should minimize. I was thinking like the middle, right? Oh, actually the one that appears the most frequent maybe? Like if we had a bunch of ones and then like a 10, we should just try to do the one that's the highest frequency. What if elements are sorted? So okay, if we sort these elements, we just need the middle. Because that will give us the like, what, like median or something? I'm not sure. Array math sorting matrix. Yeah, I don't know. Oh, sorting and median, okay. Just flatten the array. Flatten it into an array, yep. Sort it. Oh. So is it always a natural choice is the median of the numbers? Why? The median is the balance point that minimizes the total distance numbers needed to move. So I guess if the median doesn't work, then nothing else would work. That makes the problem a little bit more simple. Because before I'm like, oh, let's try the median. But what if the median isn't the minimum op? But I think it is, based off of what I read. Okay. Okay, mn length of grid at 0 for I in range m, for j in range n. Let's flatten out this array, flatten out the 2D array. So we're just going to say array.append the grid at ij. Then sort the array, array.sort the median is what we want all values to be. Target is equal to m times n is the total length, right? So m times n divided by 2? But what if it's like an odd thing? Whatever. Let's see. So the target is m times n minus 2. But it's the array at that value, whatever that value is. That's going to be the target. Now we just need to traverse the array. For value in array, the remainder should be none in the beginning. If not remainder, if remainder is equal to none, remainder is equal to the value mod x. Okay, else if the remainder is not equal to val mod x, the remainders, different remainders, return -1. It's not possible. Otherwise, just say how many it will take, right? So value mod x min ops equals 0. Min op plus equals the value divided by x. Return min ops. Let's see. Oh, we want target. We're not even processing target. We want target to have a factor. Whatever the value is, let's do target minus value. That could be a negative number. We'll just absolute value target minus value divided by x. That's how many operations. Okay. Awesome. Yeah, I mean, I failed this one. I had to look at the solution. What was bugging me is that, first of all, it's not dynamic programming, not greedy. It's one of those problems that I think these ones are kind of tough, where you just kind of have to like know a solution, right? Your brain just needs to pick up on facts, and that might be kind of hard. Um, like for me, I think two things stand out after reading the solution. The whole like the remainders have to be the same. That wasn't super obvious in the beginning, but it makes sense after reading it. So that whole like checking for the remainder, eh. And then also knowing that our target is the median, I did hint at that might be possible, but I don't have like a concrete proof of why if you had a bunch of numbers, like why would the median be the target? Yeah, I don't know. That just doesn't really make a lot of sense to me. So, I mean, that's the whole math aspect of it. I think all these math problems are pretty tricky, but either way, it is what it is. This is going to be n log n, where n is the size of the number of elements, right? And then since we're creating a flattened array, we have our space is m plus n, and then what is our time? O of, oh no, it's space is m times n, right? And then this is mn log mn, because m times n is the size of the flattened array. Yeah, and then we need to sort it, and then we just loop through it. That's fine. So yeah, um, like x log x with a space of x, just linear space. So hope you guys enjoyed this video. Not super happy about it, but it is cool. So whatever. And see you tomorrow.